I did a lot of commuting back in the 1980s, and one thing that I was always impressed with is driving around in the car. It's a difficult listening environment. You have a lot of road noise. That's going to change depending on how fast you're driving. If you're listening to a mixtape, like I was doing most of the time, I was constantly changing the volume and the tone setting on the radio to go in between songs to keep the listening, fairly consistent. So a couple of years back, when I changed out the radio on my old 1970s pickup truck, I rescued the volume and the tone knob from the dash radio. The volume had this extra tab in the back, and I was curious about this loudness tab, or that fourth lug on the volume pot. What was that for, and what purpose did it serve? So focusing on that radio that was in my old pickup truck and in the car I drove around, I wanted to take a look at the old AC Delco radios. And so I found online, a Sam's Photofact for some radios that were made in 1976. I'll provide a link for this thing in the description. And in there, I focused in on the different schematics, and I found a series of radios that had these different tone stacks. Starting off with the most easy ones, we have the Channel Master model 6348 and a Panasonic model TP800E. And these have your pretty basic volume and tone controls like you would see in an electric guitar, where you have a volume control, and in parallel to that, you have a capacitor and a resistor that lets the high frequencies roll off to ground. That's pretty straightforward and pretty common, especially from my point of view as a guitarist. But this was not the kind of tone circuit that was in my old Chevy. I had something that was a little bit closer to this. This is the American Motors 1976 series. This had a volume pot and this connection to another resistor and pair of capacitors for the bass and the treble frequencies. What's going on right here? That's that mysterious fourth lug that came out of the back of this volume pot. This was something I never really found a good explanation to looking on the internet, and I decided to do a little bit of investigation into what made these things sound the way that they did. Further on down in that document, we have a Panasonic model CQ742EU, and we also have the General Motors model 61HFM3. Starting with the Panasonic, the audio signal came in through this 2700 ohm resistor and then took a number of paths. First, going straight over to the volume, a 200K pot with a tap at 75K, so not quite in the center. And then we have these two other branches. I'll come back to that one in the center. Here we have a capacitor, we have the tone pot where the wiper goes to ground, and then we have another capacitor going off to ground. Depending on the position of the tone pot here, so this would tend to favor your higher frequencies, and turning the tone pot down, this would favor your bass frequencies. The center branch here would, bleed a couple of higher frequencies in and then go over to the tap on the volume control, and it would also let a few of the higher frequencies travel on down to ground. For the General Motors 61HFM, the signal is coming from the amplifier here. There's a high frequency path to ground, so we're losing some higher frequency information here. We have this branch for the tone control, where the up direction here is for the higher frequencies. And we have a capacitor and resistor acting as a high pass filter. So my high frequencies would come through this branch, through the tone pot, into the tap on the volume control. We also have this branch coming down here here. This is a low-pass filter feeding into the opposite end of the tone control. So these are my bass frequencies coming through here. And again, they travel on up to the tap on the volume pot. Coming off of the wiper on the volume control, I have a high-pass filter and then capacitively coupling to the following stage. So I can look at these schematics and I can kind of tell what they're doing. I can see that there's a high frequency and a low frequency branch on the tone controls, and that somehow these manage to get into the backside of the volume control and proceed on out to the power amp section of the radio. But it's a complicated enough arrangement that I can't immediately see what frequencies are getting handled and how that affects the overall signal going into the power amp section. Two other curious circuits that were in the Sam's Photofact were this Lear Jet model and the automatic model Rally 500. These both appear to have 8-track tape capabilities. Now, since these are both active circuits, I didn't do any deep analysis on these because I was more curious about the passive components with the loudness tap. But what these appear to do, we come into this first transistor and we have an inverting amplifier here and go into a second inverting amplifier. And there is a resistor capacitor down here to tailor the amplification. And then the tone control blends between higher and lower frequencies and passes them back down to bootstrap this first gain stage in the preamp. Now I also have, see, I'm inverted and I'm still inverted and I'm bootstrapping to the first gain stage again. So I understand this to a point. There is some frequency selection going on here and it's interacting with the preamp sections, but ultimately it's impacting the output signal coming to the volume control. There's a similar configuration happening over here. We have a slightly different tone pot configuration where this one is coming through one leg and going out through the wiper. This one has the outer leg and wiper connected, so this may be turning a linear pot into a more logarithmic kind of sweep. And it has the same frequency path coming back around to the first gain stage of the preamp and bootstrapping and interacting with those frequencies as this active EQ section for the output signal going to the power amp. I really didn't want to understand these in depth, but that's my quick and dirty analysis for the sake of this video. And as I did before when I stepped through the Fender Princeton Tonestack, I initially had planned on using the Duncan Tonestack calculator or any one of the other variants, but instead I went for LTSpice modeling, and I'll include all of these links in the description, as well as this excellent LTSpice tutorial by Fezzi Electronics, who has a great instructional series on YouTube, and you can see that link here. So for the analysis in LTSpice, I mocked up the circuit first for the Channel Master 6348 and the Panasonic TP800. For the model, I have an AC signal which goes from 100 Hertz on up to 30 kilohertz. And I've added this 1K resistor to act as an input impedance here to make this whole thing behave. The model for the tone pot goes from 1 to 10K, and I've set the wiper for the volume pot statically in the center, and there's a reason for that, which will become apparent when we take a look at the other models. The output frequencies are pretty much what I would expect. This is just a low pass filter going over to the volume. So as the position on the tone pot changes, gradually the higher frequencies are pulled down in this predictable kind of manner. The next case is for the American Motors 1976 series. We have an interesting set of curves here because we're affecting both the high and the low frequencies. Now for this circuit, I've modeled the tone pot again, stepping through the lowest and up to 20K for the tone pot. But here we have the first of our loudness taps on the volume control. Now for these simulations, I did not model the volume control, and I opted instead to leave the volume wiper at the same location that the loudness tap is. There's not exactly an easy way to model the volume control with the loudness tap. But just taking a look at the frequency spectrum from the changes in the tone pot, we can see when the bass frequencies are favored, they start at the lower frequencies at a little bit of an attenuation and attenuating more and more as we get to the higher frequencies. Here's that 1 kilohertz mark again. As the tone control increases, the higher frequencies are allowed to come through. As the tone control moves in a more clockwise direction, favoring more high frequencies, the lower frequencies are attenuated down and more high frequencies are allowed to pass through. There is a curious hump here that happens again right between 100 hertz and 1000 hertz. And it looks like in the maximum clockwise direction, favoring the most high frequencies, we have a fairly flat response curve. So really, my quick interpretation is this tone pot acts more like a slant control. Next up is the Panasonic CQ742EU. We have a similar circuit design here. We enter through this 2700 ohm resistor. We have what looks like the Princeton-like Tonestack with capacitor, tone pot, capacitor to ground. And then we have this pass filter here going into the loudness tap on the back side of the volume pot. Now, on the original schematic, the tap was at 75K. And for simplicity's sake, I went ahead and put the tap at 100K right in the middle of this 200K volume pot. And I ran this simulation a couple of different times, because I didn't know if a 75K tap meant that it was 75K from the bottom of the pot, or was it 75K from the top? So I wound up running the simulation 3 times, once in each of these 3 locations. It turns out it really didn't affect the frequency spectrum that much. Here I'm really just interested in what's the characteristic shape of the overall frequency response. Since it didn't affect it that much, I chose just to leave it in the center tap 100K position. Based on this configuration, there is a curious notch that occurs right here at the 1 kilohertz frequency line, maybe a little bit below that. But this is the most sensitive part of the ear, so it's not unusual to see a notch in that location. But what is interesting is at the high end of the tone control, the high frequencies are at a much higher amplitude than the bass frequencies. As the tone control moves from the high frequency to the low frequency end, the high frequencies are brought down and the lower frequencies are brought up. But we still have that characteristic notch at around 1 kilohertz. This to me was interesting because now, instead of just a slant from flat to more bass frequencies, now we have this notched slant from favoring bass frequencies to favoring high frequencies. So it looks like a pretty versatile single knob tone control. Now for the General Motors 61HF-M3, much like the radio that I heard driving around in the 1980s, the frequency responses are much more varied, favoring low frequencies, this crossover region around 1 kilohertz again, but we have this characteristic high frequency hump that happens right around the 10 kilohertz range. What makes this circuit so interesting to me is that in some follow-on analysis, I started to see how the loudness tap impacted these different frequency responses. Now, based on what I read online, the common thought was that at lower volumes, it was the lower frequencies that were accentuated. So it would give the presence of loudness at lower volumes. And I can show some follow-on analysis after this video when I figure out how to model the volume pot with the wiper and the loudness tap. Anyway, this is a curious set of curves where on the low side of the tone pot, I'm favoring the bass frequencies and attenuating the high frequencies, again, right around that 1 kilohertz region. And as I bring the tone control up, the bass frequencies are becoming more and more attenuated. And then there's this mid-range hump that happens here. And right around in the center, it's mostly flat, little bit depressed in the 1 kilohertz region, a little bit more up around maybe 3 to 5 kilohertz, and then attenuating on down as the frequencies go up. Favoring the high frequencies, the lower frequencies are attenuated down to about minus 15 dB, and then gradually rise around that 1 kilohertz mid-range until we have this hump occur in the higher frequencies. So visually, this pattern matches the memory that I have of this radio during my commute, that with just a little bit of a tweak on the tone control, I could drastically change the way that the music sounded, and I could quickly dial in something that was palatable to listen to. Now, just as a quick comparison, the Fender Princeton circuit, which I covered in a previous video, someone made the observation that this basically looks like the upper frequency part of a Baxandall or a James Tonestack. And yes, it does indeed act in such a way that this is a shelf filter where the high frequencies above 1 kilohertz or so are being elevated or attenuated, and the amount of bass frequencies that come through are largely left to the volume control. And if you're interested in more in-depth discussion about that, I have another video that I've already done on that. And if you're more curious about the effects of the loudness tap with changes in the volume control, I do encourage you to subscribe to the channel, because I'd love to see you come along for that. And in the meantime, I will have a link in the description for all of these different LTSpice models. If you want to do some additional analysis on your own, you are more than welcome to download those and experiment yourself. All right, guys, until next time, catch you later.